All right. Hey, everybody. Um, so this is the Unit 8 review guide. This will be the kind of call this the intro and page one video. Um, so as we go through this, a couple things, I'm going to focus a little bit on the right-hand rule. In fact, you know what? I'm not going to do page one of the questions. I'm just going to make this the intro video. So as we scroll through this, there's a bunch of objectives here. Make sure you can reword each of these facts or ideas as a question, maybe a couple different questions. So turn each one into like 2 or 3 questions, and you'll basically kind of have all the questions on the test because this is what they're coming from. Secondly, notice the equations. So we've got the equation for a coil, strength of a coil. The equation for the wire or magnetic field around a wire, and the equation for the force on a wire in a magnetic field. The key here, and I think we've mentioned this before, is there is no actual calculation on the test where you're going to be given, so say the coil there, you're going to be given the permittivity, the number, and the current, right? You're not going to have to solve that, but you will need to be able to tell me how it changes. So if I double the current, if I double the number, how does that change the magnetic field? As well as what are some things you could do to increase or maximize the magnetic field. So that's what those equations are there, is they're there to help you determine how increasing the distance from a wire would affect the magnetic field. We can see that that is a inverse relationship. So the further away you get, the smaller the magnetic field would get, right? As that goes up, that would make that go down. All right. So you can get that off of there. We don't really need that there. All right. And so then we keep going. Again, geomagnetism. I'll talk more about that in review class. But then, yeah, so that's that one. Next one, induction. So then the final piece is induction there, and same idea here. You have flux, but that's not what causes electricity in a loop. You need the flux to actually change. So the change in flux is the big key idea there with that, and then what changes it. So then we get to the 3 right-hand rules for it. The first one is a field around a wire where you put your thumb in the direction of the current and then you curl your fingers and it shows you the direction of the field. You need to know that it's a circle, and that we also could maybe draw this as a dot on this side and X's on this side, right? Because it's kind of going into the page here and it's coming out of the page here. So we just kind of took a cross section there. So that's the first right-hand rule. That's for magnetic field on a wire. Second right-hand rule is for a solenoid. You want to curl your fingers with the coils, with the current in the coils, and then your thumb will be pointing north when you do that, when you point it the right way. And again, you have the equations there to help it. You're not going to calculate, but you might need them. And then the final right-hand rule, I know we did it a little bit different. We actually raised our middle finger there because that's always kind of fun to stick your middle finger up. So we raised that middle finger, but you could also just call it the palm. But your thumb is the current. The finger, the pointer finger, or your other fingers are the direction of the field, and then your palm or middle finger stuck up is the direction of the force. There again, let's see here. You got thumb, field. So you got your thumb, your current, and the field, and then stick your finger out, and then that would be the force. So the force is that middle finger there. Sorry, it's on YouTube forever. Anyway, and then end up with a little bit more summary of induction there. More on that in the questions. All right. So hopefully you enjoyed this little intro, and we will get to page one next.